According to the situation given, we choose drip irrigation system as suitable irrigation system. According to Giant et al. 2022, drip irrigation system is a common micro-irrigation technique utilized worldwide to raise agricultural yield potential and enhance crop yields. Water is applied close to the plants so that only part of the soil in which roots grow is wetted. This is accomplished by using specially designed emitters and drippers. So why drip irrigation? Because we want to solve these problems. Inconsistent fruit yield, basic sprinkler irrigation, and uneven distribution of rainfall. Therefore, we have to take a look to the advantages of drip irrigation. It can save water to the extent of 40% to 60%, increase the yield from 10% to 60% depending upon soils and crops, uniform water distribution, weed growth can be reduced as well as pests and disease on durian crop.
Now I will explain about the procedure in setting up the irrigation system. For the first one, assess water supply. We need to ensure the source of water adequate to supply the system. The next one, mapping the area. Create a detailed map of area to be irrigated based on plant types and water requirements. Next, the selection of suitable system. Based on plant needs, soil type and climate, the drip irrigation were selected. Next, components needed. The dripper will surround each durian plant, so more HDPE pipe will be needed. In this project, we will use HDPE as the type of the materials. Next, for the other components such as fittings, valve, emitters, timer and pump need to be prepared for this system. Next, installing the main supply line. Lay the main supply line and connecting it to the water source or the tank. Next one, installing valve. Install the control valve at the beginning to regulate the water flow. Next, installing other components. Install other components such as timer, pump and emitter to complete the irrigation system. After that, program the timer. The timer will be programmed according to the water need and schedule. Next, system testing. Turn on the water supply to ensure the entire system for leaks or weak connections. Lastly, maintain the system. Regularly inspect the system and adjust the water schedule based on plant condition. Next, we move to the illustration of this system. In this system, there consists of several important components, which is water tank as the water source, pump, filter, control and air valve, and also the dripper or the emitter. In this project, the dripper will surround the plant to ensure the plant will get the sufficient water. So in this project, the material chosen was HDPE because it can stand the hot and cool temperature. Also, the durability is fine. The choice was made because it is easy to install the pipe to surround the plant, which better to shape other than PVC or iron steel.
Next, I will explain the irrigation schedule on specific water needs of durian tree at different growth stage. Irrigation water requirement is the quantity water supply that must be supplied to durian tree through the growing stage. Drip irrigation was used as water supply for this orchard. The average rainfall is 2,500 mm a year and 6.8 mm for each day. The table shows crop water requirements for different stages. Vegetative stage get 4.08 mm per day, and flowering stage and fruiting stage get 5.1 mm per day. Vegetative growth required 2 times per day for irrigation water. Irrigate the durian tree for 2 hours per day, which is 1 hour morning and 1 hour afternoon. For the flowering stage, the farmer need to supply water depends on flowering periods and give water to open up the flower bud last 2 until 2 hours per day. For this stage, supply the water 2 times per day. Water distribution is lower to 30 minutes once all of the flowers bloom, and increased to 1 hour once the durian fruits reach fist size. For fruiting stage, water supply need to increase about 45 until 60 minutes in all the way up to the times of harvesting productivity. For fruiting stage also need 2 times a day for irrigation water. Efficient water use considering sandy loam soil and high rainfall variability. First, plant available water holding capacity for sandy loam soil is between 1.25 until 1.40. Sandy loam as medium stature has highest water holding capacity. Soil texture sandy loam are capable for quickly draining excess water but cannot hold significant amount of water. Drip irrigation is most effective way to irrigate water directly into root zone with emitter and can increase soil water retention. Second, sandy loam soil have higher bark density which is 1.75 and higher soil compaction. The compaction soil can restrict rooting depth and reduce water uptake. Drip irrigation system can enhance the stability of soil aggregates by reducing salinity. Water irrigation with proper time management can keep the crop adequately watered at all times. Sandy loam soil also has moderate permeability which is 2.5 that based on stature. The water can move through the soil as much 6 until 20 inches per hour. Sandy loam has second highest infiltration rate with 1.835 mm per hour behind the sand soil. Low water penetration is inability of the soil to take in enough water in the active root zone to sustain the crop. The drip irrigations can increase in soil water content with the depth of 60 until 90 cm. The highly variable rainfall in dry seasons has a decisive impact on the performance of drip irrigations. Drip irrigation normally higher sensitivity to weather conditions. To ensure water efficiency use during high rainfall, adjusting the irrigation water system to be more efficient use will make interval day within 2 until 4 days supplying water. It is to avoid waterlogging at durian tree and flooding. This also can maintain water consuming energy and sustaining the durian tree growth. During high rainfall, the farmer also can commence cultivations of durian tree by utilizing water storage for the net water supply. They also can reduce pump pressure and flow rate emitter to maintain the water efficiency during high rainfall.
Next, we want to take a look to the schedule and maintenance for the irrigation system. For vegetative stage, the crop water requirement is 4.08 mm per day for the duration of 2 hours per day. Flowering stage is 5.01 mm per day for 2 hours per day, and fruiting stage is also 5.01 for the duration 2 hours per day. Next is maintenance of drip irrigation system that are divided into two. First one is weekly maintenance, which the farmers must check whether the water reaches the end of the line and check pressure differential across the filters and the flow rate. The second types of maintenance is once a few times per season maintenance, which the farmers must flush the main line and submeans to prevent accumulation of sediments that might clog the system, and conduct chemical treatment to prevent high accumulation of salts in water source and incidence of root intrusion. Next is for components maintenance. The first one is water tank. Farmers clean and chemical treated to prevent contamination or excess heavy metals to the crops. Pump. Farmers must check whether it is functioning accordingly to maintain flow rate. For filter, both screen and sand media filters in a drip irrigation system should be checked during or after each operating period and cleaned. A valve and control valve should be cleaned to properly release accumulated gases. For fittings, equal T and equal bend, it must be lubricated properly with lubricants to avoid corrosion and minimize friction loss of water. Drippers, sands, and sediments that might clog the drippers should be removed and cleaned, and Lastly, end cap connected to the end of pipelines to prevent any leaking that might flow water away from the system.